Hello my dear students, in this lecture we are going to see one previous year GATE numerical. This question was asked in GATE 2016 for 2 marks in set 1. This question was asked to find time required for the cooling, which is one of the question from transient heat conduction. So let us understand the question. The question is a steel ball of 10 mm diameter. Now here they have given steel ball. The ball is always spherical. Therefore, let us draw this ball. Let us say this is a steel ball having spherical. Right. Now it is of diameter is equal to diameter of ball is 10 mm, right, which is also called as 10 into 10 to the power minus 3 meter. Let us write down in meter. A steel ball of 10 mm diameter at 1000 Kelvin. Now initial temperature of ball is 1000 Kelvin. Therefore here Ti is given 1000 Kelvin. Then is required to be cooled to 350 Kelvin. Now this ball we have to cool up to 350 Kelvin, means the temperature of ball we have to make 350 Kelvin, right, by immersing it in the water environment at 300 Kelvin. Now the surrounding fluid is a water and the surrounding fluid temperature is 300 Kelvin. Therefore we can say the T infinity surrounding fluid temperature is 300 Kelvin, right. Then the convective heat transfer coefficient is 1000 watt per meter square Kelvin. Therefore here they have given for water H value, that is 1000 watt per meter square Kelvin. Then the thermal conductivity of steel is 40 watt per meter Kelvin. For this steel ball, they have given thermal conductivity which is 40 watt per meter Kelvin. Right. Then the time constant for the cooling process T is 16 seconds. Now this is not time, my dear students. This is not time. This is a time constant. Time constant is given here. I will tell you what is time constant. Time constant, which is nothing but 16 seconds. 16 seconds. It is not time. The question is to find time. Let us understand the question. The question is the time required in seconds to reach the final temperature is. Now, from 1000 Kelvin to 350 Kelvin to reach this temperature, what is the time required? Right. So here time small t in seconds we have to find. Right. And time constant is given. Now, my dear students, let us assume lumped heat capacity analysis. That is, lumped heat capacity analysis is nothing but transient heat conduction. And my dear students, for this transient heat conduction, we have derived the formula. That is, the formula is final temperature T minus fluid temperature T infinity divided by initial temperature Ti minus fluid temperature T infinity is equal to e to the power exponential power minus HA divided by rho VCP into time T. Right. Now, my dear students, can I say this equation is a unitless? Here, temperature divided by temperature, Kelvin divided by Kelvin, or degree Celsius divided by degree Celsius, it is a unitless or it is dimensionless, right? It must be unitless. Therefore, this exponential to the power, this must be unitless, right? Therefore, my dear students, here this HA divided by rho VCP into T is unitless, right? And we know that the unit of time is second. The unit of time is second. Therefore, this complete term must have unit of 1 upon second. 1 upon second. Right. And my dear students, the reciprocal of this is called time constant. Therefore, here the time constant, which is nothing but in second, is nothing but rho VCP divided by HA. And this constant they have given 16 seconds. The reciprocal of this will become second as 1 upon second. The reciprocal of 1 upon second is second. Therefore, this value they have provided. Therefore, here HA divided by rho VCP is nothing but 1 upon 16. Therefore, can I say HA divided by rho VCP is equal to 1 upon 16, right? 1 upon second. 1 upon 16, that is 1 upon second unit, right? So, my dear students, this complete term is given, all the temperatures are given, and our target is to find this time. So, let us use this formula and let us find this time, right? So, my dear students, here, so we understood that what is the given term. Time constant is nothing but rho VCP divided by HA. This is called time constant. Just now we have written. Therefore, let us write down the formula. T minus T infinity divided by, we can say Ti minus T infinity is equal to e to the power minus T divided by time constant. Just now we have derived this formula, right? So my dear students, let us put the values. Therefore, T is given 350 minus T infinity is 300 divided by Ti is 1000 minus T infinity is 300 is equal to e to the power minus T divided by time constant is 16. Right. So my dear students, let us solve this equation for T. Now, if I consider ln function on both sides, that is log to the base e, then I will get answer ln of 350 minus 300 is 50 divided by 1000 minus 300 is 700 is equal to minus t by 16. Therefore, my dear students, this time will become minus 16 into ln of 50 divided by 700. So let us solve this for time. Then time you will get 42.23 seconds. So here we can say this time is nothing but time required to cool this steel ball from 1000 Kelvin to the 350 Kelvin in a water environment. So my dear students, here your answer in the fill in the blanks. They are asking in second. You can check here in second they have asked. Therefore your answer is 42.23. Thank you dear students. In next lecture we will see one more numerical on this topic which was asked in previous year GATE examination.